Well, hey, it's Dr. J. And as promised, I'm back with an application of indefinite integrals. So, this is a classic business application. It's based on all the concepts that we've seen in the past. So, let's just sort of dissect it. The marginal revenue from selling 80 gallons per day of ice cream is $2.8 per gallon, or in other words, $2.80 per gallon. We can start writing this down. So we'll let, as usual, we'll let X be the quantity. So X1 will be 80 gallons. We'll just put 80. And then our marginal revenue, now let's be careful. Marginal revenue is the derivative of the revenue function. So it's like the slope at that point. Yeah. So I'm going to put R prime, and then we'll put a subscript of 1 to indicate it's our first marginal revenue. $2.80 per gallon, or 2.8. Okay. Let's keep going. When daily sales decreases by 20%, so 20% of 80 is 0.2 times 80, which is 16. Yeah, 20% of 80. So it's decreasing by 20%. So that means X2 is 80 minus 16, as we're decreasing by 20%. And so that'll be 64 gallons. Another way to do this would be to just multiply 80% of 80, which would be 0.8 times 80, and that would automatically give you the 64 directly. So either way, you can do 20% and then subtract, or you can just do 80% and then either way you land. Whenever I do these problems, I might be weird, but I do it both ways to make sure that the two numbers agree with each other. Because if these don't agree with each other, then either I have no idea what I'm doing, or I made some minor calculation error. Okay, probably going to need a calculator next. So the revenue increases, the marginal revenue increases to $3.44 per gallon. So that means our R2, not P2, because it's not profit yet, or price. It's the revenue, marginal revenue, so that's the derivative of the revenue function, actually increases to $3.44. Now, when I first started learning business calculus, I was a little surprised by this fact, that how could the revenue go up when the sales go down? Well, the key is the word marginal. All right. The revenue actually is going up. Obviously, if you're selling more gallons of ice cream, right? So this one's 80 and this one's 64. The actual revenue would be larger for more gallons of ice cream. So the revenue for X1, the actual revenue, is higher than the revenue for X2. However, the marginal revenue, the margin is that little slope line that we talked about, the increase, the amount of increase for each additional sale or each additional unit is going to go up, right? When you sell less. And it's interesting how that works, but you got to just kind of either draw a very, very accurate graph and look at the slope at each point, and you'll see that when you sell less ice cream, or it doesn't even have to be ice cream, the individual increase for each unit is going to be more when you sell less. So as the margin decreases, the revenue, as the sales decrease, the margin increases. Okay. Now our goal is to find the daily profit function. So we're going to need to analyze the cost. Let's go ahead and wait on the cost. Let's find the revenue first. All right, we don't want to put in these production costs quite yet. I need to get deeper into the problem before we're not ready for cost. We have to make some revenue first. All right, so now this should all be a review of the previous business math that we've learned in the past. So let's see. So our goal is to find R as a function of X, then find C as a function of X. All right, and we'll wait on that. I mean, you could do it right now if you really wanted. I better do it before I erase these. And then finally, find profit, capital P. So we got sort of three steps. First we find R, then we find C, and then we put the revenue and the cost together to find P. All right. Let's see. I don't want to lose this, so let me write it down. So the fixed costs are I'm just going to write fixed is 288. And the variable cost, var cost is 2.5. So in other words, each gallon of ice cream variably, as I make more of it, that's like per gallon, it's based on X, is $2.50. But then every day I have to spend $288 just to keep the ice cream factory open. All right, so first let's find R. So we don't know what R is, but we do know that R prime 1 is $2.80 and X1 is 80 and R prime 2 is $3.44 and X2 is 64. So let's find the slope. So that'll be 2.8 minus 3.44 over 80 minus 64. All right. The R's are like the Y's. So in your mind, think of this as Y. Right? So when you do the slope, Y is on top. Right? It's always the rise over the run, and then the run is on the bottom, so the X's go on the bottom. It's very easy to screw this up. I've done it myself. I've done this whole problem with this upside down. And then one of you out there, you probably know who you are, will email me and go, Dr. Jordan, the answer's not working. And I'll be, because I typed it upside down. All right. And as soon as I find out that I typed something upside down, I go and fix it right away. So thank you for paying close attention to detail. You know who you are, and you will be rewarded. I forgot my calculator. I'm going old school today. Old school 1990s calculator here. So we'll go 2.8 minus 3.44. That's negative 0.64 divided by 16. So I get negative 0.04. Okay. So that's my M. All right, now we got to find B. Yeah. There's several ways to do this. The most common way to do it is just to pick one pair. You have to pick a corresponding pair and then plug it in. Remember the formula y equals mx plus b from basic algebra. You get a lot of mileage out of this formula. You learn this formula in an elementary or sometimes an intermediate level algebra course, and you get a lot of mileage about this. You just solve it. B equals y minus mx. Right? Basically moving the mx over to the other side with the y and then writing it in the form of an equation. B equals. And remember, think of these marginal revenues as being like your y's. So your b is going to be 2.8 minus m, which is negative 0.04, times x, which is 80. And it doesn't matter which pair you pick. So pick a pair. Make sure you pick the corresponding pair, though. So you wouldn't want to pick like 64 and 2.8. That wouldn't work. And then just do this on your calculators. So you've got negative times a negative is going to be a positive, times 80. So that'll be 32. 2.8 plus 32. So that'll be 34.8. Let me double check that. 0.04 times 80 is... Got to look very closely, and I'm so glad I checked. When I first looked at that, because I haven't been using my old school calculator in a while, although they still sell these. I think you might be able to find one at Walmart or Walgreens or something. I thought that said 32. Look very closely. That is 3.2, right? So as soon as I saw 34.8, I immediately thought something's got to be wrong. So it's 3.2 plus 2.8, which is 6. So that is my revenue prime. Is mx plus b. It's not my actual revenue, it's my revenue prime. It tells you the marginal revenue function of a particular, it's a marginal revenue function. Marginal revenue function. In other words, if you want to know how much you're making on the margin, right? That's what we say in each increment or each additional gallon. This tells you the additional revenue from selling the next gallon. Okay. Now, what does this have to do with integration? Well, we know how to go from a derivative now, at least presumably we know it because we just saw it in the last video, to go from a derivative back to the function that created it. So we're going to use the indefinite integral to find r. So we say the indefinite integral of negative 0.04x plus 6 with respect to x is going to be negative 0.04x squared over 2. Right? You got to add 1 and then divide. So add 1 to the power. That makes it 2. And then divide. Divide by the new power. Plus 6x. Right? The integral of 6, or the antiderivative of 6 is 6x. And then plus the constant of integration, which is c. So our r of x is negative 0.02, because you're dividing, x squared plus 6x plus c. Now you got to find c. Okay. So this requires a little thinking now. This is a revenue function, right? What is the revenue from selling 0 gallons of ice cream? Pause, wait for it. 0. So that's the question. The answer is 0. So in other words, the revenue of $0 of 0 gallons is $0, right? In other words, if you don't sell anything, you don't make anything, right? Remember, revenue functions always start at 0, 0. That's just a common sense fact of business. I mean, it really has nothing to do with calculus. This is just a basic fact of business. You sell nothing, you make nothing. The cool thing about it, though, is you're not losing any money, right? So remember, this is just revenue. That's why I always wait on the cost. Cost will come later. All right. And so now that means that negative 0.02 times 0 squared plus 6 times 0 plus c is equal to 0. Right? We take this revenue function, we plug in 0, and we find what the value of c is. Well, not a big surprise. You should not be surprised that c is in fact 0. Yeah. In fact, you really could have skipped this step if you have a good memory of chapter 1, 2, and 3, right? I mean, we've been doing this for a long time now. Revenue functions never have a constant term, right? But I went through the whole, rigmarole. I couldn't think of another word for it. So the revenue function is just the first 2 terms. There we go. Check. So we're done with the revenue. Next, we need to find the cost. Cost is very easy. Cost is variable cost times x plus fixed cost. Right? I mean, unless told otherwise, this is the general, we call linear model for cost. So cost is $2.50 times x plus 288. And that's it, folks. Once you have the revenue and the cost, it's all downhill from here. You can then find the profit function. I always write it this way. Profit equals revenue minus parentheses cost. That keeps you from screwing up the form. Also keeps me from screwing up the form. Anytime I warn you about a mistake, it's usually a mistake that I've actually made or one that I've seen other people make repeatedly. And this will give you your final answer. You see how important the parentheses are. They give you a distributing property of multiplying by -1, thereby changing the 2.5 to negative and changing the 288 also to negative. And so your final answer is given here. And that's it, folks. I only have time for one application in this introductory section. We'll do more applications later. if you are interested, so I'll say DIY. There's lots of things you can do. You could draw the graph. Using X and Y. It would start way down here at negative 288, right? We say you always wake up every morning in the hole, right? Especially when you're in business, right? You got to get up, you got to make money. You got to work 7 days a week sometimes, right? And then the profit would be like a parabola like this, right? And then this would be the optimal, just kind of a review in case this is on the final. Optimal production level X. I'll leave that as a do-it-yourself. You know it from the last chapter. Just take the derivative, set it equal to 0, and find this here. And then this would be the max profit. Right there, yeah. You probably wouldn't want to produce past that. So, I mean, even though the graph is technically a full parabola, you really would want to stop right at the maximum profit. Anything beyond that, you're essentially losing money. It means you're spending more than it's worth, right? And we'll talk about that later in the chapter, how to prevent that or what to do with the surplus. Right, you got a bunch of leftover ice cream, and you don't want to put it out into the market. What do? Maybe you lower the price. Maybe you have a discount sale. We'll talk all about producer and consumer surplus later in the course. And then one thing we actually never talked about, which I kind of just escaped me, because it's more of an algebra problem and not a calculus problem, is finding this point right here. That's an interesting point. This is called the break-even point. We did talk about the point of diminishing returns. We did talk about that. It's not the same thing, but it's by far not the same thing because it's not changing concavity here, but it is changing from negative to positive. So there is a distinct change happening at the break-even point. It's where you go from, we call this in the red to being in the black, right? You go from losing money to making money. Again, the answer to this question is here. We're done here. But DIY, I always encourage you to investigate a little bit further what this actually means and what additional types of questions we might ask in this course. Well, that's it for this short lesson. We'll come back with more next time. But until then, I'm Dr. Jordan, and I'll see you on the internet.